Hello everyone, I am Sai Pranit. Today I will be presenting our work on spatial and temporal modeling alternatives for human-object interaction. This work is co-authored by Rishabh Dabral, Srijan Sarkar and Professor Ganesh Ramakrishnan. The task of HOI involves identifying relations between humans and objects in a scene. However, HOI detection in videos is a challenging task as the framework has to account for changing orientations of objects. We use the CAD 120 dataset where HOI is formulated using human subactivity labels and object affordance labels annotated for every segment of the video. Every segment can be interpreted as a simple subactivity like moving a cereal box or pouring milk, and these subactivities together add up to the high level activity of video like making cereal or microwaving food. It is also important to capture temporal information from previous segments as this can provide a strong prior for inferring the current subactivity. For example, in this video, if the person lifts a cereal box, it can be anticipated that he pours cereal into the bowl in the next segment, and after the cereal has been poured, it can be anticipated that the box will be placed back. Prior frameworks proposed for video HOI detection model the video as a spatio-temporal graph. However, these methods use handcrafted features derived from ground truth information like 3D pose coordinates and object centroids, making it difficult to extend them for in-the-wild videos. Recent works on HOI detection in images propose to use additional levels of representations present in images. The framework we use for video HOI detection can be broken down into 4 major steps. In the first step, we use bounding boxes of humans and objects to crop out corresponding image areas and compute visual features for each node using the backbone module. The second step is the spatial subnet, which learns the local interactions between humans and objects in a single frame and outputs spatial embeddings for each human and object node. The third step is the frame level subnet, which captures the temporal relations between various frames within a single segment and refines the node embeddings. The fourth and the final step is the segment level subnet, which leverages prior temporal knowledge from previous segments while predicting HOI labels for the current segment. So the 3 levels of interactions captured by this pipeline are the relations between nodes in a single frame captured by the spatial subnet, temporal relations within a segment by the frame level subnet, and inter-segment relations modeled by the segment level subnet. In our first formulation for spatial subnet, we use capsule networks which have proven effective in encoding spatial information and view invariant properties. Apart from visual features from human and object bounding boxes, we also extract the visual features from global hull bounding box, which covers all objects in the scene. This helps to incorporate a wider image context which is otherwise absent in node features. The primary and secondary capsule layers generate capsules out of visual features obtained from the backbone module. We concatenate the capsule features from global hull of the scene to human and object capsules. The concatenated features are then flattened and processed using a linear layer to get spatial embeddings for each node. We perform capsule routing using variational Bayes algorithm. In another formulation for spatial subnet, we use an adaptive variant of GCN where the adjacency matrix is augmented with adaptive and data-driven components. Here B is the adaptive component which is tuned during the training process, and C is the input-dependent component which is computed uniquely for each input. Coming to the results on CAD 120 dataset, we evaluate our model for HOI detection and anticipation tasks using F1 score as the evaluation metric. We achieve the state-of-the-art performance on HOI detection tasks while using GCN formulation for the spatial subnet and achieve comparable performance while using capsule networks. Although our pipeline is designed primarily for HOI detection in videos, we extend our model for HOI detection in images by using embeddings from spatial subnet directly for classifying action labels. While using capsule network formulation of spatial subnet, we achieve comparable performance with role map score of 47.2. In summary, we analyze the performance of various spatial and temporal models for HOI detection in images and videos. We explore uses of capsule networks and show their efficiency in modeling spatial relations. Furthermore, unlike the existing methods for HOI in videos, our method scales well to in-the-wild videos also. And finally, I'd like to thank you all for listening to my presentation.